Hello, GH101. We're going to do another sort of classic beginning programming exercise, and in particular a simulation. I put a spot in our boot camp for simulation. So the idea is that we want to use the computer to see what happens. And there's examples that are pretty important where this happens. So for weather, the government and researchers and forecasters, how do they figure out what's going to happen with the weather? So one of the ways, part of the forecast, is taking the current known state of the weather. So that means temperature, pressure, etc. at all weather stations. Right, so there's a weather station in Terre Haute. There's more than one actually. So you can take all of those temperature, pressure, wind speed, everything that they measure. Also potentially satellite and radar images from around the world as well. So you take all of that and put it into a weather model. Run the weather model to see what happens. So the weather model is supposed to take the current state of things and go forward in time a small amount. Okay, so so what you can think of is an easy example is take a, let's just say, similar to taking the current position and speed of a ball and predicting where it will be in, say, 10 seconds or 1 second or something like that. Okay, so there's equations where you can say, let's see, there's a picture. So these are math equations that if you take, let's say we have a ball that we threw and it's at this point and we know how fast it's going and we know the strength of gravity, then you can predict in 1 second where is it going to be just by the equations from physics. Okay, so for weather there's more equations and more things going on, but it's the same basic idea where there's going to be some equations for the weather. There'll be lots of equations that go into this because there's a lot of weather stations and a lot of stuff going on. But it's the same basic idea where you have the current state, where's the ball now, and how do things change, what are the equations, and then run it. Okay, so weather's one, planet and star formation is another. So if we want to understand how the solar system formed, then what we can do is have a inside the computer some millions of small particles of dust, or maybe more like trillions or however many, lots, and put in the equations of physics and run it forward. Same type of thing. We'd have the equations of physics to say if my dust is somewhere and it has some initial velocity and then it would go in some direction, and you do that for all of the particles of dust. Let all of the particles of dust move around, right? And as they move around, they start affecting each other because the laws of physics say that this happens. And then you just run it. You just let it go one step at a time. run the simulation one time step at a time. So we'd say my particle is here, and then after 1 second it will be over here, and then after another second it will be over here, and then we just see how it goes. And that's one of the ways that we understand how star systems form and how planets form. All right, another example of a simulation that's important is how many lanes do we need for highways, and other roads. Say, all right, so we can put into the computer, you know, so let's just say for some city, let's say 100,000 people who come from random locations across the city and go to random other locations for work, maybe centered around the city center at roughly the same times. Okay, then what happens with traffic? So you would have their car, we'd have some equations that start their car at their house and move it along their route to work at some speed, except if they have to wait for other cars, right? So we have all these cars, and we put in equations for how they travel and how they stop at stop signs and traffic lights and things like that, and then we can run it and see what does the traffic look like. Run it with say, you know, 2-lane roads or with 4-lane roads. You could change different roads in the computer to have a different number of lanes. Maybe run it with stop signs versus traffic lights. Okay, so we could change all those things and run it and see what the traffic looks like. All right, our simulation, we're just going to do basic probability of flipping some coins. And we'll see something come out of it that's kind of cool. So this is just in the category of basic probability. There's lots of areas where simulation is an important thing, right, that gives us important information to design things and understand the world. We're going to go with coin flips. I'm going to start a new R script and call it coinflips.r, and this is what I want to do. So I want to flip a coin 10 times and count how many times it is on one side or the other. In the US, we have heads and tails. So I'm just picking one of the sides to call it the head side. And so what I can do is I can use my sample int function. So if I say that it's going to be one of two choices, then I can do this. I'm either going to get 1 or 2. I'm getting a lot of 1s here, but sometimes I'll get a lot of 2s. All right, so I'm going to do that up here, and I'm going to do it 10 times. So for I in 1 to 10, I want to flip a coin. Okay, and maybe I'll just print those coins. So here we can see how many were 1 versus 2. All right, so I'm going to count. I'm just going to say, let's say a 1 is heads up and 2 is heads down. So I'm going to count heads up. I started at 0, and then if the coin is 1, then I'm going to say heads up is heads up plus 1. And I'm printing it as well, and at the end I'll have my heads up, right, my count of that. Okay, so I'm 10 times, flip a coin. If it's 1, count it as a heads up. See how many we get at the end. So did I get 6 here? There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this is good. This is probably correct. Looks correct. All right. So what do you think is the average value? If we run this a lot, what do you think the normal value should be? So your intuition might tell you about half of the time, right? So about 10 times or about 5 times. So what is the most likely value for heads up? Your intuition tells you half of the total. So half of 10 is 5. So we'd expect it to be kind of close to 5 in general. Anything can happen, right? You can have a bunch of heads or a bunch of not heads. But in general, you kind of expect 5 to come up more often. So what I want to do is run the 10 coin flips lots of times and keep track of how many each total happens, right? So what I'm thinking of doing is I want to have a variable called heads up. I'll call it total counts, just as something. So what I'm going to do is I'm going to call this as a I want to make this as 10 different, actually 11 different zeros. So I want to have something that is initialized as 0 for all possible total. Note that the possible totals are 0, 1, up to 10, right? I could have 0 heads, or I could have up to 10. That is 11 possible totals. So what I want to do is have a variable that starts off with zeros 11 times. And so the functions that we have to do this are see and seek at the moment. Okay, so let's see. See these are examples of using the see function to create a list. What about seek? That's not the one I want to use either. So let's just ask the internet. So we're going to ask the internet R, create an array of zeros. Stack Overflow normally has a couple different options. That is good. Rep, that's what I wanted. Okay, so I want to do, let's say, total counts equals rep. And I want to repeat 0 11 times. I believe that's the way that works. So let's see, total counts. It says there's 11 of them and they're all 0. That's good. All right, and what I want to do is whatever the heads up value is, I want to say that I'm going to increase that by 1. Okay, so if my current value of heads up is 4, then I want to increase this by, so in the 4th spot there's a 1. Let's say that I run this again. So now I've got 6. I'm going to run this line here. Now there's a 1 in the 6. Question: what happens if what if heads up is 0? Okay, so if heads up were 0, let's just put that in just to try. So it could happen. It's not very likely, but it'll happen sometimes. So if heads up is 0, then I want to run this here. And what changed? It doesn't look like anything changed in my total counts. I can view it to see there's the 4 and the 6 that I put in, but that's it. The reason is because in R, you can't, if you put a 0 here, it starts counting at 1. So the first one is the 1 there. So if I say 0, there actually is no 0 position in the total counts. So the way to fix that is I'm going to do it like this. So I'm going to add 1. Okay, so if heads up is 0, then that goes into the count in the first slot, right? Because 0 plus 1 is 1. If heads up is 10, that goes into total counts in the 11th slot. Okay, so this first one here is for counting how many times we got a 0 for the total, how many times we got a 1, 2, up to 10. Okay, so let's start this over again. That's all zeros. I could run this total, so the heads up is 4. I'm going to comment this. I don't want to start it over again. So I added 1 in the 5th position because this is for 0 for the heads up, 1, 2, 3, 4. I could source the file and it'll run everything. And I got another total of 4, got another total of 5, 8. So we can see the values here changing as they go up and up and up. And let's see, 0, 1, 2, 3, 4, 5. That's position 5, and that is the highest, right? So 5 for the total. I'm going to put in something to print this here. So for all the positions in my total counts, so I want to say heads up and I minus 1 happened, total counts I times. Okay, so what I'm going to do is I'm going to go through total counts from position 1 up to 11, and I'm just going to print that out. Let's see. So I have position 0, heads up 0 happened 0 times, that's the 0. 1 happened 0 times, 2 happened 2 times, and so on. Okay? So what I want to do is run this a lot. I want to run this first part here a lot. I'm going to stop printing the heads up because I want to run it a lot. I'm going to stop printing the coins because I want to run it a lot. I don't want all that printing. And I'm going to start the total at right at the zeros, but then I want to only do that once and then run it a bunch of times. So I'm going to move this up, and I'm going to say, let's put this into a function. So do 10 flips. So I want to do 10 flips, and I'm going to have a totals, what was it called? Total counts. So this is the thing that I want to have happen over and over again. And then I'll return the total counts. Okay, so do 10 flips. I have to give it my counts as a parameter, and then it's going to modify potentially one of those and then return it. So then my main program can be like this, and then I do 10 flips and I give it total counts. All right, so let's see. I need to run on the function, saves that as a function now. Start the total counts at 0. I did 10 flips, and that added 1 to whichever one it was. Now if I stay here and I'm doing Command or Control Enter here, this is doing 10 flips and updating that total counts. And then I could print them all here. All right, so I actually want to do this a lot. So let's say 1 up to 1,000. And maybe I'll print that out. Flipping 10 coins 1,000 times. I do it, and then I print. And we can see that 5 is showing up the most, which is cool. Let's put it up to, say, 2,000. Okay, and you may notice something interesting about the pattern here. So it should be the case that 0 and 10 are the most unlikely. So how many, if you flip 10 coins, what's the chance none of them are heads? Pretty small. What is the chance that all of them are heads? Pretty small. It's a little bit more likely that you get 1 or 9. It's a little more likely than that you get 2 or 8. And 3 or 7, 4 or 6, and 5 is the most likely, and the reason is because of, it's not complicated, but it'll take 20 minutes to explain, so we're not going to here. But you might notice the pattern here is sort of similar to the pattern that we got with our binomial program. If I open up my binomial program, wherever that is, so I run this here was 10, the binomial coefficients 10 choose 1, 10 choose 2, up to 10 choose 5. Okay, and let me just go back to 1,000 here on this one. So the numbers are sort of, they're not going to be exactly the same, but the pattern and how they grow and shrink is the same. And it's actually the case, it is the case that the numbers printed are related to the binomial coefficients of 10 choose I. This 10 choose I, I'm not requiring you to remember this, but the probability of getting I heads is 10 choose I divided by 2 to the 10th power. So that 10 choose I is in there. So this is the probability that you're going to get 5 heads, and then the exact number that you get here, it's going to depend on how many times we did this. Okay, that's not required, but if you're a math person, you can think about that or ask about it. All right, so this is simulation. It's kind of interesting. We could do different simulations like this. What happens if we, instead of flipping a coin, what if we rolled dice and looked at the most common outcomes? All right, for now though, that's the end of coin flipping.